Alright, so for problem 7, to solve it, we can see that it already fits a separation of variables technique pretty well, given that the independent and dependent variables are already pretty much separated out. So we're going to go ahead and divide over by y squared. And now we can basically integrate it out. Alright, this is a pretty easy integral to do. There's not going to be any real hiccups along the way. So we're going to have something like, it'd be awesome if I could integrate correctly. Alright, and the constant of integration. So with this problem, we can see we can actually get it in an explicit form. Since there's only one y in here, it'll be pretty easy to do that. So we're just going to go ahead and divide everything over. So it's going to be -1 over minus c. And there is our solution. Oh, fuck. Alright, so to solve this initial value problem, we're going to use separation of variables because the dependent and independent variable are already pretty much separated out. They're just waiting for us to divide them out. So our first step, annoying. So our first step is going to be divide by y squared on each side. Alright, and then we can integrate this bad boy out. Now this is a pretty easy integral, so not going to give us any real trouble. And don't forget the constant of integration, of course. So we notice that we can pretty easily get this in explicit form since there's only one y. So we're going to go ahead and do that. And now we notice that this is an initial value problem. So we can actually solve for this constant of integration. So we're going to go ahead and do that. We're going to plug in 0 for t and set y equal to -1/6. So we're going to have this is pretty easy. It's basically just saying that c equals 6. So now we can just plug that back into our solution. So finally we will have y of t equals -1 over t minus t squared plus 6. And there's our solution.